Hello, my dear students. Welcome back to one more lecture on advanced econometrics. So, in last lecture, we discussed how we can rationalize the Koyak model by incorporating the idea of adaptive expectation. Okay, so by incorporating the adaptive expectation hypothesis or error learning hypothesis, okay, we have converted an equation into yt is equal to gamma beta 0 plus gamma beta 1 xt plus 1 minus gamma yt minus 1. Okay, so the original equation was y the original equation was something like, yeah, yt is equal to beta 0 plus beta 1 x star t plus u. Okay, that means yt, the demand for money, is a function of expected interest rate. Since the expected interest rate is not directly observable, we have borrowed the hypothesis of adaptive error learning hypothesis or adaptive expectation hypothesis. By including the adaptive expectation hypothesis, we have converted our model into a model called yt is equal to gamma beta 0 plus gamma beta 1 xt plus 1 minus gamma yt minus 1 plus ut. Okay, but now you look at the equation, there is no y star or there is no stars. Okay, all are current terms. Yt is current yt, okay, xt is current xt, and yt minus 1. We are including the lagged, there is a lagged values of the dependent variable. Okay, so this is basically an autoregressive mod. Okay, now today what we are going to discuss is how we can numerically explain or how we can numerically estimate this model and how we can derive this gamma beta 0 beta 1 1 minus gamma etc, and how we can interpret the result. Okay, so for explaining these things, let me take a data. This is the data consumption expenditure. Okay, consumption expenditure is depends on disposable income. Both are current values. Okay, so if you take the Milton Friedman consumption hypothesis, it is consumption is depends on not only the current income but expected incomes. Okay, or expected lifetime income. So the expected lifetime income is not directly observable. So we have converted this model into a model like uh, expected income. The consumption is a function of gamma beta 0 is an intercept, gamma beta 1 xt is nothing but the current income and the previous income. Okay, so how we can estimate? Go to day. Now you look at, this is the dependent variable, this is the independent variable, this is the dependent variable lagged values. Okay, so the data is only available from here onwards. So we go to data regression. Okay, you click the dependent variable. This is the dependent variable and this is your independent variable. Yes. Okay, no label is available, you just click OK. Yeah, now you look at this equation, we are getting an intercept. Okay, this is the intercept, this is the slope 1, the slope 2. Okay, so look at this, what is our intercept? Intercept is nothing but gamma beta 0. This is the, yeah, what is intercept? intercept is not only beta 0 but the gamma beta 0. Okay, so the gamma multiplied by beta 0 is minus 1242.17. Then beta 1 value is not directly available, but gamma beta 1 is available. What is gamma beta 1? It is 0.60. Okay, so gamma is not available, but 1 minus gamma is available. What is 1 minus gamma? 0.41 is the 1 minus gamma. Then what will be the gamma? 1 minus gamma is 0.41. Then what will be the gamma? You can subtract this 0.41 from 1, then you will get gamma coefficient. Okay, so if 1 minus gamma is equal to 0.41, then gamma will be equal to 0.58. Okay, so now we have derived, or we have estimated the expectation hypothesis. How much people are adjusting their expectation? It is around 0.58. Okay, that means people are adjusting around 58% of their expectation in each year. Okay, now if you look, now we have estimated this equation. Okay, this is a newly derived this equation. Okay, so we have estimated this equation, but basically we don't need this equation. But what we have to do, what we have to find out, actually we have to find out this equation. We have to find out yes, actually we want to find out this equation. In this equation there are two coefficients, beta 1 and beta 0 and beta 1 is there. Okay, so from the equation that we have estimated now, gamma beta 0 plus gamma beta 1 xt plus 1 minus gamma yt minus 1, from that equation we can derive the value of beta 0 and beta 1. Okay, so how we can do that? Beta 0, this is gamma beta 0 is equal to minus 242.17. Then what will be the gamma? Beta 0, this divided by your gamma. Yes, beta 0 is equal to minus 2107.82, minus 2107.82. Then what is beta 1? This is actually gamma beta 1. So if gamma beta 1 is equal to 0.602, then if you divide this with your gamma coefficient, it is 1.02. Okay, so we have estimated the equation of the original equations from the adaptive expectation equation. Okay, so what we have done is we had an equation like yt is equal to beta 0 plus beta 1 x star t plus ut. Since x star t is not directly observed, we cannot obtain the data on x star t. So we, at that point of time, we could not explain or estimate beta 0 and beta 1. Okay, so in order to get this beta 0 and beta 1, what we have done, we have incorporated the idea, or we have borrowed the idea of adaptive expectations. Okay, and by incorporating the adaptive hypothesis, we have converted our original equation into an autoregressive equation. Okay, now we have first estimated the autoregressive equation, and from the coefficient of this autoregressive equation we have derived this coefficients of the original equations. Okay, now the original equation is equal to original equation is minus 2107.82 plus 1.02386 into x star t. What does it mean? if expected interest rate is increased by 100%, okay, then the demand for money will be if it this is not the case of the demand for money. Suppose if it is demand for money data, then or suppose this is the example of consumption, okay. So in this consumption example, we could say that if consumption uh, if expected income increase by 1%, okay, if expected income is increased by 1%, then the actual current expenditure will be increased by 1.02%, okay. Yes, so this way we can calculate or we can estimate the adaptive exploration hypothesis, okay. Yes. Okay, thank you then.